All right, remainder and factor theorems. Blast and pass. There you go. Plug 3 in for all your x's that live in Texas. Bless you. -3 times 3 squared plus 5 times 3 plus 4. And then do your order of operations. So square 3 first, which gives you 9. Good. Plus 5 times 3 plus 4. Do those multiplications. 9 times -3, -27, plus 5 times 3, which is 15, plus 4, -27 plus 15 plus 4 gives you -8. Old stuff. Easy enough? Great. Here's where this changes today. We're going to do 2 different applications of synthetic division. All right? 2 different applications of synthetic division. The first one is a shortcut to doing this work. Okay? Instead of doing it like this, you can do it like this. You can take the coefficients from here, 3, 5, or -3, 5, and 4, set them up in a synthetic division. Okay? And here's the trick, and here's the hard part. And then you take 3 and you put it in your box. Now, why do I say that's going to be the hard part for this type? Why is that the hard part? Jocelyn.
Because last time we were doing this, we flipped the sign.
Good. Okay. Here you have to decipher when do I switch the sign and when don't I? Because we're doing both types today. Okay? First type, we don't switch the sign. The second type, you do again. Okay? And there's a way you can tell when you should and when you should not. Bless you. Okay? Here you shouldn't. Okay? Here you shouldn't. So, you leave 3 alone. And then you do your synthetic division. You bring down -3. Multiply -3 with 3 to give you -9. -9 plus 5 gives you -4. -4 times 3 gives you -12. -12 plus 4 gives you -8. So on this type, since we're trying to do a shortcut to evaluating functions, instead of plugging this 3 into here and doing all this and all that again, you just do this. And your answer is your remainder.
Will it always be the same?
Same how? Same process?
No, the same debate and -8. Will it always be
Oh, yeah, both, yeah. Well, not -8, but the same thing, yes. Yeah.
the same.
Like, not the answer to every question in the world is -8. Correct, yes, but it will be the same both ways. Okay. Boy, that'd be easy. Here's a quiz. -8, -8, -8, -8. Done.
Jesus.
There you go. Yeah, -8, Jesus. Mormons rocks. -8, done. Boy, that'd be a good quiz, wouldn't it?
Yeah.
Yeah. Okay. Make sense so far? Okay. Here's a couple more. Okay. So your next one, f of x equals 3x to the 4th minus 2x cubed plus 5x plus 2. Find, bless you, f of 4. Okay? Now, here's how you know you don't switch the signs. Okay? You don't switch when most typically you see an f. Function notation. Okay? If you see function notation, f of x, f of 4, you don't switch. All right? That goes for any function letter you typically see. Usually f, g, and h, right? Those are your 3 big function letters. F, G, H. You see one of those 3, don't switch your sign. Okay? Now, before you all get ahead of me, because I know some of you that love synthetic division are probably ahead of me. Make sure you're paying attention to your synthetic division rules from yesteryears. What's missing?
That's what I was just talking about. The x.
The x squared is missing. Good. And when something is missing, you need to put it in. How so? With a 0. Perfect. Man, I feel like I did teach you guys something last semester. It feels so good. Put in a 0x squared because you don't have the x squared in the original. After that, set everything up. So we don't switch our sign. So we put in a 4. 3, -2, 0, 5, 2. Bring the first one straight down. Right? That's why you put that arrow in there. Remember that? Put that arrow there so you bring the first one right down. So, 3 times 4, 12. 12 plus -2, 10. 10 times 4, 40. 40 plus 0, 40. 40 times 4, 160. Good. Okay? 160 plus 5, 165. 165 times 4, 660. Good. 660 plus 2. There's your answer. And there's no rewriting on this version either. Okay? You notice that? There's no rewriting of your polynomial because that's not what you're after. That's not what you're doing. This is a usage of synthetic division. Last semester, when we just did synthetic division, we just did it. Okay? And we're going to rewrite again in a minute. But whenever you're just doing evaluations, okay, whenever you see function notation, you don't switch your sign, you don't need to rewrite those two things, okay? Any questions? Okay, next one. F of -1, so -1 goes in your box. Bunch of missing stuff here. We got an x to the 5th. We don't have an x to the 4th. We got an x to the 3rd. We got an x to the 2nd. No x to the 1st. And then -1. And see, I think like a problem like this is where this comes in way more handy than plugging the -1 in here, here, and here. And then getting lost in your exponents, right? Like, for example, if you plug in 4 and you plug it in here, 4 to the 4th, you know, that's a big number. Then times it by 3, that's a bigger number. That's easy to get lost in, you know. Now, I understand the answer is 662, and I understand there's mistakes to be made other places. I feel like this process is easier than the work through here. I really think this is easier, okay? So if I see these in this next test coming up, this way, all right? So this one.
You're saying you can't put the 4 in?
If you want to put the 4 in and check it, I'm fine. But I'll be looking for this work. Okay. So 4 times -1, -4, add it to 0, -4, times -1, 4, plus 2, 6, times -1, -6. Add 1, -5, times -1, +5, add to 0, that's a 5, times -1, -5, add a -1, -6. Okay. But see, and here's my point. Here's kind of my point with this. I didn't have to worry about a single power, okay, on that one. Think about this. I didn't have to worry about a single power. I didn't have to worry about, okay, -1 to the 5th. -1 times -1 times -1 times -1 times. Okay, that's 5 times. That's a negative, which makes that a -4. Didn't do that one time. All I did was multiply and add. That's all you did the whole way through. So I think, and I agree, I think in certain cases it's easier just to plug the number in and just do it. I think in a case like this, where it's easy to get lost in your exponents, which is my new favorite saying for this lesson, I'm going to write that down. I think this way is faster, much nicer. Okay. Any questions so far? Everybody good? All right. That's one application to this, to synthetic division. That's a good one. A second application of this is called the factor theorem. Okay. Now, the one we just did, which was technically the remainder theorem, I didn't put that anywhere, but that's what it's called. Okay, it's the remainder theorem. That one is, if you're going to call the synthetic division problems that we did the first semester, and then that type and this type, if there's an oddball of that group, it's the one we just did. He's the strange one. He's the one of your family you never want to go talk to because he's so weird. Okay? The other two are very similar. All right? And you're going to see that as we work this next one. So, to show this in an example form, instead of just trying to explain it to you exactly how we do it, we're going to take into account this one right here. Okay? 2x cubed minus 3x squared minus 17x plus 30 divided by x plus 3. You do a synthetic division with that, all right? Since you don't see an f or a function notation at all, notice how you switch that sign again. All right, see that? You go from a positive 3 here with the x plus 3 to a negative 3 in your box. That's the differences. If you see an f or a function notation, you don't change the sign. If you don't see it, you do. Okay? It's kind of backwards logic, but it's how it is. Okay? When you do that synthetic division, you bring the 2 down, multiply by negative 3, get negative 6. Add, multiply, add, multiply, add. You get 2, negative 9, 10, 0. Okay? Everybody with me? 0 in this case is what? What's it called? The last number of these synthetic divisions is always your remainder. Good. Now, okay, we got to take this one step further. What is 12 divided by 3? 4. Because 3 divides 12 4 times blank. 3 goes into 12 4 times blank. What's that blank? Finish my thought.
Period.
No. That comes after the blank. 3 goes into 12 4 times blank.
3.
No. Or here, let me rephrase it just a little bit. 3 goes into 12 blank 4 times. 3 goes into 12 blank 4 times. The blank is a word. I know times is a word. The word starts with an E.
Equals.
Close.
Equal.
No. What?
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 Can you repeat it? What you said?
3 goes into 12 blank 4 times. You guys are gonna kick yourselves once I say it.
Put one extra. It starts with an E.
Starts with an E.
Wait. Is it like a math word?
It is. You guys are gonna kick yourselves so hard.
It's close to equals.
Equality.
No. Equivalent, no.
We haven't.
Give us the next letter.
V.
Every.
Book? No.
Ever.
Yeah, we'll do it eventually, apparently, but
Ever. I don't know. Even. Every.
finish.
Evenly.
There you go.
Oh, yeah.
Evenly.
Yeah,
Okay? 3 goes into 12 4 times evenly. Evenly 4 times. Whenever you divide a number evenly, it means you have a remainder of what?
Two, even number.
No.
Oh,
When you divide a number evenly, your remainder is always what? 0. Good. Okay? Now, here's what we got to do. We're going to take this from numbers that we all know and love to polynomials that some of us have a love-hate relationship with. When you're in number world, you divide it by evenly, or you divide it evenly by a number, you get a remainder of 0. Okay? Here, we got a remainder of 0. Okay? Now, whenever we rewrote these last semester, you would always drop down one exponent, right? You'd get 2x squared minus 9x plus 10. Okay? Since you've got a remainder of 0, that tells you that x plus 3 divides 2x cubed minus 3x squared minus 17x plus 30.
Equal.
So close.
Evenly.
Evenly.
Oh, equal.
Evenly. Okay? Now, I'm going to throw in one more F word at you. Not the one you're thinking of. 3 is a blank of 12.
Factor.
Factor, good.
Yeah, we got that one.
Save some time here. Which means x plus 3 is a factor of 2x cubed minus 3x squared minus 17x plus 30. It's one of the parts that make up that polynomial. Okay? Make sense? X plus 3 is one of the parts that make up that polynomial. What we're going to do is find the other parts. Okay? Now, we're not going to do it on this one. We're going to stop here with this one except for a definition. All right? This guy down here has a special name. The polynomial that you get, that you rewrite, has a special name when its remainder is 0. It's called a depressed polynomial. Why it's called depressed, I don't know. I guess it's sad that it lost one of its buddies. I don't know. It's by itself. It lost one of its factors, so he's sad. I don't know, but it's called depressed polynomial, so we're going to roll with it. Depressed polynomial, by definition, is the result of dividing a polynomial, which is the 2x cubed minus 3x squared minus 17x plus 30 part, by one of its binomial factors, which is x plus 3. Okay? If you're going to make this work, you must divide these evenly, which means your remainders must be what? 0. Good. Good. We're making connections now. Pistons are firing.
okay.
Okay?
Is that going to be the same? Is 2x squared going to be the same answer for the next question?
No, not necessarily. These can change.
Probably that's what.
Those can change. Okay? Yeah, those can change. Everybody kind of on the same page with all this. Okay? Let's do it. So, determine whether x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. Then find the other factors of the polynomial. So first off, you're given a binomial and a polynomial. They want you to figure out if that binomial is a factor of that polynomial. You do that with synthetic division and getting a remainder of 0. So you set that up. They give you x minus 5, so we're going to put in the box positive 5. You set your division. 1, negative 7, 7, 15. You do that division. You bring the 1 down. 1 times 5 is 5. Negative 7 plus 5 is negative 2. Negative 2 times 5 is negative 10. 7 minus 10, negative 3. Times 5, negative 15, to give you 0. That's a good thing. If you don't get a 0 on these, and this is the part of today where it's going to be the worst part, keeping track of your rules amongst the two types that we do. Okay? If you don't get a 0 on the ones when you got to do the factor theorem, you did something wrong. Because they're all going to give you remainders of 0. Here. The other type, they can be remainders of 1,012 if they really wanted to. One of them on your homework is large. It's like in the 13,000s, I think. I might be wrong. It might be an even question. You guys have odds. I'm not sure. But it's possible that you get huge numbers. Here, your remainders are 0 every single time. So if you don't get one, you mess up. Okay? Okay. Now, since you got a remainder of 0, you have confirmed that x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15. Now the bottom sentence. Find the other factors of the polynomial. So write your depressed polynomial. Oh. And then what? Starts with an F. Factor it. Good. So we need a multiplied number of -3 and an add number of -2 since there are 3 terms. This type of factoring never goes away. Don't ever forget this. This never goes away. All right? So you need multiply number -3, add number -2. Make it happen, captains. What you got?
X minus 2, parentheses, x minus 1.
That'd multiply in +3. Multiply to -3, add to -2. How about a -3? And +1. Alright, so x minus 2, factor of x cubed minus 7x squared plus 4x plus 12. 2 in your box. That looks like a 3. Let's try that again. There we go. Alright, 1, -7, 4, and 12. Bring down the 1. 1 times 2 is 2. Add to -7 gives you -5. -5 times 2, -10. Add to 4 gives you -6. -6 times 2, -12. Add to 12, you get 0. Rewrite it. X squared minus 5x minus 6. And then factor it. Factors how? X multiplies -6, add -5. So x minus 6 and?
X plus 1.
Good. X minus 6, x plus 1. Page 290, 9 through 23 odd.